There's this entire invisible world all around us, working at a completely different level. Today, we're going to crack open this secret playbook that allows these tiny microbes to not just survive, but to completely dominate their environments. Let's get into their secrets. So what is their secret? Well, it's not random at all. It turns out microbes follow a surprisingly specific set of rules, a survival guide, if you will, and it dictates literally everything about how they grow, multiply, and take over. And why should we care about their playbook? Because knowing these rules, well, it's crucial for pretty much everything. I mean, think about it. Preventing infections in hospitals, making sure our food is safe to eat, even pushing the absolute boundaries of scientific research. It all comes down to understanding how these little guys grow. So let's dive in. We're going to start with the engine that drives this entire invisible takeover, a fundamental process that's happening inside every single cell all the time. It all starts with metabolism, which is basically the cell's internal economy. And it's split into two key processes. On one hand, you've got anabolism. That's the construction crew. It uses energy to build complex cell parts from simple stuff. And on the other hand, you have catabolism. That's the demolition team, breaking down nutrients to release that very energy. Build up, break down. It's just this constant, amazing cycle. Okay, so to fuel that engine, what exactly do microbes need to eat? Let's open up the first chapter of their survival guide, the diet plan. Just like any living thing, microbes need their main course, what we call macronutrients. And the two most important items on the menu, the absolute heavy hitters, are without a doubt carbon and nitrogen. These two are the cornerstones of life. And just look at the central role carbon plays. Calling it the Lego brick of life is no exaggeration. It makes up about half of a cell's dry weight, and it's used to build everything. Proteins, DNA, the works. Some microbes, the autotrophs, are super resourceful. They can build with simple CO2. But others, the heterotrophs, are more like us. They need to eat complex organic stuff. So if carbon provides the bricks, then nitrogen is what builds all the machinery. It makes up around 13% of the cell, and it's absolutely vital for proteins, which are the cell's workers, and for nucleic acids, like DNA, which is the cell's blueprint. Without nitrogen, nothing gets built, and no instructions can be read. Simple as that. But of course, it's not just a two-element show. There's a whole supporting cast here. You've got phosphorus, which is crucial for making DNA and cell membranes. Sulfur is needed for key amino acids. And then elements like potassium and magnesium, they act like the oil in the machine, helping enzymes do their job and keeping everything stable. And finally, you have the micronutrients. Now, these are like a tiny pinch of salt in a giant recipe. You only need a little bit, but they are absolutely critical. Iron is a perfect example. It's essential for producing energy. Vitamins fall into this category too, acting as little helpers for all the cell's enzymes. Small, but mighty. All right, let's move on to the next chapter. See, a great diet isn't enough. Microbes are also incredibly particular about their living conditions. They need the perfect environment. And factor number one, without a doubt, is temperature. This graph shows it perfectly. Every microbe has its cardinal temperatures. Down here at the minimum, things are just too slow for growth. As the temperature rises, the growth rate shoots up to this peak. That's the optimum. But if you push it past the maximum, the cell's insides literally fall apart. It's game over. And this graph brilliantly shows just how specialized they can be. You have psychrophiles that actually love the freezing cold, and on the complete other end, you have hyperthermophiles that thrive in temperatures way above boiling, like in deep sea vents. Most of the microbes we deal with, though, are these mesophiles right here, living comfortably in the middle range, just like us. Okay, so they're picky about temperature. Got it. What else is on their environmental checklist? Well, next up is pH, and it's pretty much the same story as temperature. Every microbe has its preferred zone on that acid to alkaline scale. You've got acidophiles that thrive in really acidic places, like a stomach, neutrophiles that prefer a neutral pH, like in our blood, and alkalophiles that love alkaline conditions, like you'd find in a soda lake. Then there's water, and it's not just about being wet, it's about water availability. This image here shows exactly what happens when a cell is in a super salty or sugary environment. All the water gets pulled right out of the cell, that's osmosis, and the inside shrinks. It basically dehydrates the microbe to death. And finally, there's the big one, oxygen. It's a real spectrum here. For some, the aerobes, oxygen is absolutely essential for life. But for others, the obligate anaerobes, It's a deadly poison. And then you've got all these types in between, some that can take it or leave it, and some that need just a little bit. A microbe's relationship with oxygen literally defines where it can live. So this is where it all comes together. This is the payoff. Now that we understand the rules of their survival guide, their diet, their perfect home, we can learn how to hack their growth code. And the crazy thing is, we already do this every single day. We control temperature with refrigeration to slow them down and sterilization to kill them. We control water by dehydrating foods or curing them with salt. We control pH through things like pickling and fermentation. And we control oxygen with a vacuum sealing. Every single one of these is a direct hack of a microbe's fundamental needs. You know, the source material for this explainer puts it perfectly. By understanding the conditions that microbes need to grow, we gain the power to control that growth. This knowledge isn't just for a textbook, it's the very foundation of modern food safety, medicine, and public health. So we know their rules, and we know how to bend them to our will. But here's the thing to remember. Microbes have been on this planet for billions of years. They are nature's ultimate innovators, and they are constantly adapting. Which really leaves us with one final big question. What will their next move be?